Hello everybody, today I can factor tricky trinomials using the bridge method. And here are the notes on the bridge method in case you want to take a picture or a screenshot or whatever of these to refer to. And I'm just going to go right into a couple of examples. Notice there are two scenarios for the ending of this. The first three steps are always the same, but at the end it's going to be a little bit different depending on if one of the factors divide or if they both reduce. So number one, is there a GCF? No. Dots, no. Trinomials, yes. What makes this a tricky trinomial is there is a value in front of the x squared or y squared, which makes it a tricky trinomial. And to factor tricky trinomials, I use the bridge method. So step one is I build a bridge between my first and my last number. Technically what I'm doing is I'm multiplying, and that product goes in the back. Now, whenever you go over a bridge, if you go over, the George Washington Bridge or the Verrazano Bridge, Throgsneck, you always have to pay a toll. That's going to be a later step. So whenever I build my bridge, I like to write PT for pay toll at the end of it, because it's very common for students to miss that step. So writing that there will help you not miss that step. Next, I factor my trinomial normally. If you don't know how to do that, refer to my video on regular factoring of trinomials. Y and Y, the first sign comes down, negative and a negative is a positive. What multiplies to 14 and subtracts to 5, 2 and 7, bigger number comes first. All right, so that step is just a regular factoring of trinomials, which we did in a previous lesson. Now it's time to pay the toll. Pay the toll means divide by the leading coefficient. Since I multiplied by 2 at the beginning, now I have to divide by 2. Now there's two scenarios. Scenario one of them divides nicely. Well, this divides nicely. So if one of them divides nicely, divide them. 2 divided by 2 is 1. And for the other one, the denominator goes in front of the variable, and the rest of it stays the same. And that's bridge method. So again, I start by building a bridge. I'm multiplying the first and the last number. That goes in the back. I factor the trinomial normally. I pay the toll, which is dividing by the leading coefficient. Scenario 1, if they divide nicely, divide them. 2 divided by 2 is 1. And for the other factor, I put the denominator in front of the variable. Number 2 is pretty much the same exact procedure. Again, I'm going to build a bridge from my first to my last, since there was no GCF and it was a trinomial. Don't forget to pay the toll later, so I'm going to write that now. 2 and 8 is 16. Next, I factor the trinomial normally. X and X, first sign comes down, positive and a negative is a negative. What multiplies to 16 and subtracts to 15? 16 and 1, bigger number comes first. Pay the toll. Divide by what I multiplied at the beginning, by the leading coefficient, by what's in front of the x squared. If one of them divides nicely, divide them. Yes, 16 and 2 divide nicely. 16 and 2 is 8. For the other one, put the denominator in front of the variable. That's your answer. Let's skip to number 5. Why don't you try number 5 on your own? So please pause. Try number 5 on your own, and then unpause. Okay, is there a GCF? No. Dots, no. Trinomials, yes. Bridge, yes, because there is something in front of the y squared. So I'm going to build my bridge. Don't forget to pay the toll later. I'm multiplying the first and the last number, which gives me 3. Next, I factor the trinomial normally. First sign comes down, positive and a positive is a positive. What multiplies to 3 and adds to 4? 3 and 1, bigger number goes first. Pay the toll! I'm dividing by the leading coefficient, which in this case is 3. If they divide nicely, divide them. 3 over 3 is 1. And the other one, the denominator comes in front. Now, let's take a look at scenario 2. Let's jump back to number 3. Is there a GCF? No. Dots, no. Trinomials, yes. Bridge, yes, because there's something in front. So I build my bridge. I write pay total. Nothing is different. At this point, I factor the trinomial normally. X and X, first sign comes down. Positive and a negative is a negative. What multiplies to 12? And subtracts to 4. 6 and 2, pay the total. In this case, I'm dividing by 4 because that's my leading coefficient. That's what is in front of the x squared. That's what I multiplied by at the beginning. Now, in the other examples, one of these divided nicely. In this case, they don't divide nicely. If they don't divide nicely, you need to reduce the fraction. So this is 6th, 7th grade stuff. What goes into both 6 and 4? 2. So I can take a 2 out of both of them, and I get 3 over 2. What goes into both 2 and 4? 2. So I take a 2 out of both of them, I get 1 over 2. If you can't do 6th, 7th grade reducing of fractions, you can do it in the calculator. If I want to reduce 6 over 4, to type a fraction in, I go alpha y equals, enter. 6 over 4.
Excuse me.
Sorry, I got a little lost there. So alpha y equals, enter. Type in 6 over 4. It spits the answer out of you. 6 over 4 reduces to 3 over 2. Again, that's alpha y. Oops, I hit the wrong button there. Alpha y equals, enter. So for the second one, 2 over 4. And it spits the answer out at you. So to reduce the fraction, you either know how to do it by hand from 6th or 7th grade, which I just showed you, or worst comes to worst, you use the calculator. Now, I put the denominator in front for both of them, so it becomes 2x plus 3 and 2x minus 1. You could always do a quick check, which may eliminate some potential mistakes. If I multiply 2x and 2x, I get 4x squared. So if your quick check doesn't work, that means you probably made a mistake. Number 4, GCF no, dots no, trinomials yes, bridge yes. So we build a bridge, we pay the total. X squared plus 13x plus 30. Factor the trinomial normally. Again, whether we're doing scenario 1 or scenario 2, it still starts the same way. And again, if you can't factor a regular trinomial, go back to the previous video, which is factoring using GCF dots and trinomials. What multiplies to 30? 1 and 30, 2 and 15, 3 and 10, 5 and 6, and adds to 13, 10 and 3. Pay the total. Neither of them divide nicely, so we have to reduce. I can take a 2 out of both of those. That becomes 5 over 3. I can take a 3 out of both of those. That becomes 1 over 2. Now, I put the denominator in front. And I got 3x plus 5 and 2x plus 1. So I want you to try number 6 on your own right now. So please pause. Try number 6 on your own. Unpause. Now that you tried number 6 on your own, I'll go over it together. Is there a GCF? No. Dots, no. Trinomials, yes. Bridge, yes, because there's something in front. I call it a tricky trinomial. To factor tricky trinomials, we use our bridge. Don't forget to pay the total later. I'm multiplying the first and the last number to get 24. Y and Y. First sign comes down, negative and a negative is a positive. Again, this is just regular trinomial at this point. Which of those pairs subtracts to 5? 8 and 3, bigger number goes first. Pay the toll. Neither of them divide nicely, so scenario 2 is I reduce each of them. Just go a different color for that. That might be a little bit easier to see. So I can take a 4 out of both of those. I can take a 3 out of both of those. Or you can let your calculator do it for you. That's 2 over 3. That's 1 over 4. Then the denominator goes in front. And your final answer, 3y minus 2, 4y plus 1. If I want to do a quick check, 3y times 4y is 12y squared. So, when you're factoring a trinomial that has a leading coefficient other than 1, a tricky trinomial I call it, we use the bridge method. The bridge method, the notes are listed for you here. Again, you're building a bridge, you're multiplying the first and the last value, factor the trinomial normally, pay the toll. Scenario 1, if it divides nicely, divide it, and throw the denominator in front of the variable for the other one. Scenario 2, reduce both of them, and then throw the denominator in front for both of them. Practice, practice, practice. Have a great day.